Hello, everybody. Homer White back again with the second screencast on Chapter 10. This is not closely associated with anything really in the textbook, but it's just some further practice in the pipe and dplyr manipulations and ggplot2 in connection with a special data set on baby names. So we're going to need to use the Babynames package, which is installed on RStudio. And so you'll want to library Babynames. I'm going to do that right now over in my RStudio. Okay. And let's study the data table a little bit. We should get some help on Babynames. And I'll pop that help up big. So full baby name data provided by the Social Security Administration. It's going to include information on all names that were used at least 5 times in a year for a baby. I think there are some privacy considerations that keep them from including data on very, very rare names. So what you get, accordingly, of the variables appear to be what year it was, the sex of the baby that gets the name that's being used. N is how many babies of that given sex were born with that given name in that given year. And prop here is n divided by the number of babies who were born with that name in that year of that gender. So prop is short for proportion. Okay, why don't we go ahead and get a view of it as well? Or how about just, let's just type it into the console and look at it as the tibble that it comes to us as. So remember, every row really stands for a set of people. So this first row here is the set of all females who were born in 1880 and who were given the name Mary. There were 2,065 such people, at least that we know of, that were born in hospitals where we could record their name. And the proportion of all females born in 1880 who were named Mary is 0.0724. So 7% of the females born that year were named Mary. And then, a similar row for the set of all females born in 1880 who were named Anna. So lots and lots and lots of rows, nearly 2 million rows. Okay, so let's ask ourselves a question. How popular has the name Mary been over the years? So what we'll do is we'll take Babynames and pipe it in as the first argument to the filter function. We're going to filter for the name to be equal to, quote, Mary. And so now we just get the Marys. And then we'll make a new column called pers, short for percentage. And it's the prop times 100 to turn the proportion into a percentage. And then we'll take that whole data table there and pipe it into ggplot, aesthetically mapping the x-axis to year, the y-axis to the percentage. And geom line is a nice way, it's like a scatter plot, but it connects the points so you get a little line graph. And we're going to aesthetically map color to sex of the baby. And you may wonder why when they're named Mary. Well, we'll see in a minute. So what does this look like? Looks like this. And notice there are 2 line graphs. And the reddish one is the females, the turquoise one is the males. So again, you can see that a little over 7% of the females born in 1880 were Marys, That percentage declined. Mary got a jolt of popularity shortly after World War I, but then the decline set in again until now the name is kind of rare for a female. Uh, Now, there is a line graph for males. Apparently, there are just a few males born each year who are named Mary. Who would have thought? It is important, I think, to be looking at the proportions or the percentage rather than the numbers. What would happen if I had asked the same thing but aesthetically mapped Y to N, the number of people with the given name in that year of that gender? Then we would have gotten a rather different impression. It would look as if the name Mary became more popular and then less popular, but that is really not so. What's happening is that between 1880 and 1920, there was, first of all, a great increase in the US population, and there was also a great increase in the tendency of people to use a hospital for birth rather than doing a home birth. And so the numbers available to the government just skyrocketed. And of course, then the number of Marys would go up as well, even though relative to the population as a whole, Mary was getting to be a less popular name. So, how popular has your name been over the years? And why don't you work with percentages rather than the absolute number of births? So, I'll tell you what, I'll go back and steal this code here and give it a try in RStudio. But my name is Homer. And I'll change the title too. Notice the cool trick. Quotes are used to delimit strings. So if you want quotes inside a string, you need to escape their special delimiter meaning, and that's done with a backslash before the quote. So now I can have quotes inside around Homer inside the title. So give it a try. And zoom it up big. And you'll see that that Homer reached the height of its popularity, never very popular, never more than 0.25% of boys being named Homer, reached the height of its popularity somewhere around late 1800s, but then underwent a great decline to the point where Homer might die out. Who knows? And again, strangely, there's a few females born with the name Homer, or are these strange typos or errors in the data? One wonders. Just want to show you some of the many other flourishes and tricks with ggplot2 that we haven't examined yet. What if you wanted to mark a certain date in a Babynames graph? For example, think about the important pop star Prince, who released his classic Purple Rain album in 1978. That was a real breakout, and it made him a star. Is it possible that his stardom influenced name making, and maybe you see more people being born with the name of Prince? So we're aiming to make this graph here. So it's a graph that shows just the boy babies and the percentage of them that are born with the name Prince over the years since 1970. And you can see a kind of a skyrocketing in popularity, shortly after 2000. The year 1978 is marked with this blue line. And if you think about it, 1978 to 2000, it gives people who maybe were quite young in 1978 and were listening to pop music, it gives them time to grow up, have children of their own, and start to decide to name them Prince. And of course, he has other. He continued to be very popular until his death, and more so. And so, of course, more and more children ended up being named Prince. up to 0.05%. Still not a very great popularity. How would you make this? Well, starting with baby names, you would certainly want to filter for name to be equal to Prince and year to be bigger than or equal to 1970. And if you want just the boy babies, you just need to say and sex has to be equal to male. So having caught just those rows, you pass that data table with the pipe into the mutate function to create a new column called purse, which is prop times 100. Pass the resulting data table with the pipe into ggplot. And then aesthetically map X to year, Y to purse, geom line. But here's the new thing. Add on another geom V line. And that stands for vertical line. And vertical lines have an x-intercept where they hit the x-axis. If you aesthetically map x-intercept to just a number, 1978, then that one vertical line will hit the x-axis at 1978. And then we'll fix the property of color to be purple for that line. So, and then of course, labels in the usual way. It's fun to compare names, to kind of be competitive. Which name's more popular? So how about a little head-to-head matchup here? Which name for males has been more popular over the years, Homer or Stanford? Those are two rare male names, but which of them is more rare? Baby names, piped to the filter for sex to be male, and names to be in percent. What a useful little function in the concatenation of Homer and Stanford. So if your name's Homer or your name's Stanford, you're going to make it through this filter and be piped to the mutate that creates the new column purse. That gets piped over into ggplot. Again, X goes to year, Y to purse, geom line, but we aesthetically map color to name. That's the key. And that gives us this plot that we see here. And so we see Homer was quite popular and got a decline. Stanford has never been popular, but by now it's about as popular as Homer is. Both names are on the outs. Let's just play around with some ranking with the flier. What are the top 5 most popular female names for each decade from the 1950s through the 2000 aughts, so 2000 to 2009? So here's the code for that. I'm going to do some dplyr work, but I will be binding the name tops to the resulting data table using the little assignment operator here. So we start with baby names, and we filter for the year to be at least 1950, but less than or equal to 2009, and sex to be female. And we need to create a variable for decade. So decade equals, what we'll do is we'll take the year and divide by 10. Like a 1952 divided by 10 would be 195.2. But the floor just whacks off the decimal place and leaves us with 195. Every year in the 1950s, from 1950 to 1959, would get the same floor after this operation, 195. Every year in the 1960s would get the floor of 196, and so on. So I'm going to use that little decade variable to group the data by decade. And then within decade, we will group by names. And so, for each decade, there's going to be, for each decade, for each decade and name group, say like 1950s and Mary, there's going to be 10 rows because you've got a Mary for every year from 1950 to 1959. And so there's a lot of these little groups, and each of them is 10 years long, 10 rows in size. Now, once we've done that grouping by, we're going to summarize where the total is the sum of n. Remember, n is how many born in that year. So if you sum the n variable within the group, you get how many babies were born with that name in that whole decade. Now, that total variable, that's the one you're going to use to rank people by. We're going to pipe that into a top n function from the dplyr package, which takes the top number according to some criteria. How many do you take is your first argument. We'll take 5. What's your criterion? We're looking at which had the highest totals. That's given by this WT weight parameter here. And then finally, we'll arrange the whole data set by decade. And then within decade, we'll arrange by total in descending order. So let's give this a try over in RStudio. It takes just a tiny second, and then it's done. Let's take a look at tops. So in the 1950s, see where we have decade here. The most popular name was Mary with a total of 625,558. So even though Mary has been getting less popular over the years, it's still a very common name compared to other names. Linda was the next most popular, and so on. Starting in the 1960s, Lisa is the most popular, then Mary. So Lisa has eclipsed Mary. In 1970s, the 5 most popular are Jennifer, then Amy, then Melissa, then Michelle, then Kimberly, and so on through the 80s, the 90s, and the aughts. So if you want to understand better how this data wrangling is completing its task, you can do it by running successive lines and stopping before a pipe. Like you can start with tops and you can just filter for those years and female. And so you see tops has quite a few rows here, 727,000 of them, because we've just done that filtering. And now we'll create the decade variable. And we'll go from having 5 variables to 6 variables. We'll do the group by. And if you look over in your global environment, when I run this, you don't see a change, but the grouping has been done. It's been attached to the data frame. So it's ready for the summarize. And the summarize is going to cut this way down. And so now we have 137,000 rows of just 3 variables. The 3 variables that are left are going to be the 2 that you group by plus the 1 variable that you're summarizing into. So we have decade, name, and total. That's all that you're going to have for tops. But within each of those groups, you want to take the top 5 names. There's a lot of names that make up each little decade group. We're taking the top 5 when we run this. And so now when we look at it, we can see there's only 5 in each group. The next thing we're going to do, though, is we need to arrange things in order. And so we arrange by decade, which is already apparently going to be done, but we also want to arrange by total in descending order. That's not been done yet. Look, Mary was the most popular, but she's only number 3 on this list. So heading back to our code, when we run it all down through the arrange, then we get the tops that we looked at first. Running dplyr wrangling line by line like that is a really good way of understanding how the code is doing its work and learning new dplyr commands. There's a data table of the same thing. What if you were to reverse the order of grouping? So, like, say that you did the same data wrangling, except instead of grouping by decade, comma, name, what if you grouped by name, decade? What would happen to you? I'm going to bind the name bad tops to the result of this data wrangle. Let's see what would happen to us. Go to RStudio. And it takes a little moment. And it takes rather a long moment. And I think I have a mistake somewhere. Some error in the code. I can't see where it is, though. Error in baby names. To filter, could not find function. That's very strange. That should be no problem. Should be no problem at all. Very strange. Let me run this again. Yeah, it worked. Whoop. Who knows what's up? But anyway, if you take a look at bad tops, it's really not going to be what you want. You get a lot of the same data. The problem is that when you go for top 5, you'll see that you're really you've got a whole lot for each decade. There's a tremendous number of them, and in way more than I can count. There's 132,000 rows here, and basically there's like 6 decades involved. About 20,000, over 20,000 in each group when you summarized. And the problem was that reversal in the code. If you group by name, then you are going to automatically have hundreds of thousands of groups right there. And then within each name you group by decade, then what you're doing is when you summarize, you are looking at the popularity of each of the names over the decade, sure, but when you take the top in, you're looking at the top 5 decades for each name, which is not what you want. So the order in which you group can be important. That's the idea of this last question. So that's it for our practice. This should get you ready for the homework in chapter 10.